Okay, hello everyone. Guys, I just want to take a little closer look at this vertical motion problem. This isn't a worksheet you have to do, it's just kind of like some notes. And there's an example on the next page. Just in case you wanted to print it and just have it for yourself, okay? Again, in a vertical motion problem, the quadratic is expressing the height of the object as a function of time. Okay, that's where that h of t comes from. That's just height. That's different than the h we're talking about with the vertex. That's not the same h, like hk. That's not the same. That's just the height of the object, okay? Now, if we graph this quadratic, the x-axis is the height at some given time, all right? And the y-axis is the height of the object at some given time. The x-axis is the amount of time passed since the object was first launched into the air. All right? So again, this is just height. Now we're using feet. Feet per second. That's what we're using. So we use this -16 in front. Guys, if we were using something different, like meters per second or inches per something, this would be different. We're using feet per second. That's why this is 16, okay? V initial, this is the velocity that starts at. The vertical velocity at the launch, straight up, okay? And HO is the height it starts at. Sometimes if it starts on the ground, then this H is 0. All right, the H sub O is 0. But if it starts up on, sometimes it starts higher up off the ground. So we have to add that back in, okay? Again, initial height at the launch, initial vertical velocity. All right? Guys, the x-coordinate of the vertex, all right? That's the time it takes for the object to reach its maximum height. And that's something that you're asked a lot. So you need to know how to find it. All right, remember, there's a formula for finding the x-coordinate of the vertex. It's -b over 2a. All right? B is always the initial velocity. That's the B right here. Remember, this is A, B, C, like that. That's standard form. All right? B is always the initial velocity. That goes on top. Again, this is a negative. And A is always -16. Always. All right? Because we're using feet per second. Okay? Guys, the y-coordinate of the vertex. Again, think of something, it starts here, it goes up, and then comes down. Something like that, okay? We're talking about right here, the vertex. The x-coordinate of the vertex was how long it took to get to the top. The y-coordinate of the vertex, the y, all right, is the maximum height reached by the object. That's how high it went before it started coming back down. That's the y-coordinate of the vertex. So remember, after you find the x-coordinate of the vertex, just plug it back into the original equation. That's what the t is. Oops. That's what the t is. T is x, okay? Just plug it in once you find it. And that's how you find the y, just like we did before. We're looking for the vertex. Right, the vertex. The x-coordinate is how long it took to get to the top. The y is how high the top is. All right? The x-intercept, and that's coming down to right here, where it hits the ground again, back to 0, if this is the x-axis. All right, and this is called, we'll call this the y-axis right here. Okay, so when it comes back down, that's where it crosses the x-axis. That's where y is 0. Well, how do we find that? We factor it, remember? That's factored form. Factored form is where it crosses the x-axis. That's easy to find it that way. So the x-intercept is how long the object stayed in the air before it hit the ground. We launched it and went, we hit the ground. This distance, how long this is the time it took in the air before it hit the ground. All right? Now, when you factor it, you're going to get a solution back over on this side, too. All right? This is the one that doesn't make sense in the real world because we launched it up here. Okay? Only one reasonable solution. Now, guys, I want to look at an example. This is an object that's going to be thrown straight up in the air. We started from a height of 48 feet, initial velocity of 32 feet per second. All right? The time it takes to reach the top is the x-coordinate of the vertex. And remember, that's negative b over 2a. All right, so that's what I put here. This is b over 2 times a. All right, it's negative 32 over negative 32, 1 second. It took 1 second to reach the top.
Pardon the interruption. FYI, tennis is canceled.
All right, guys, sorry about that. We had a couple of announcements. I'm at school right now. All right, guys, the bell just rang, so we might be some people walking through the halls. All right, again, the time it takes to reach the top is the x-coordinate of the vertex. You find it using that formula. All right? We found it to be 1 second. So how do you find the y-coordinate of the vertex? You plug it back into the original equation. Okay? And again, our equation, guys, is right here. That's the equation. Again, 32 feet per second is the initial velocity, and it's launched from 48 feet high. All right, so I just plug in 1 where t is. 1. That's what I did right here. 1. We ended up with 64 feet high. That's how high it goes. All right? That's the maximum height. But, however, how long is it in the air? How long? Well, guys, you can put it in Desmos if you want, which is what I did, too. I just found out where it lands right here. We'll go through that in a minute. But I can always also factor it. All right? Negative 16 I can take out of all three of those terms. So I just end up with this quadratic right here. A little easier to factor. T minus 3 and t plus 1. So by factoring, we'll see that the x-intercept is either 3 or negative 1. Well, guys, negative 1 doesn't make sense, all right? So what we can say is that the object was in the air for 3 seconds. Let's look at the graph. Now, I kind of spread this graph out, guys. The y-axis goes up by 10 here. Okay, and the x-axis just goes over by 1. I just want to spread it out because it gets so thin. Again, guys, the x-intercept behind here at negative 1, it doesn't make any sense in this context because we launch it from right here. It launches from here, goes up to the top, and then comes back down and hits the ground. Now, the reality is it might have just gone straight up and down, but we're measuring as a function of time. Time is ticking away down here, okay? The initial height of the object is the y-intercept, 0.48, right there, okay? And the vertex is right here, and that vertex is 164, right here, okay? 1, because it took 1 second to get to the top from the launch, and 64 is how high it went at the maximum height. Then it comes back down and crashes into the ground right here. That x-intercept is 3, 0. Again, 0 means it's on the ground. 3 is how many seconds it took. Here, 1, 2, 3, and then hit the ground. Okay? So the object was in the air for 3 seconds. Guys, use this. This might help you. Okay? Guys, I hope that worked. I appreciate it. Thanks.